Hey everyone, and welcome back to this class, Advanced Convolutional Neural Networks. In this lecture, we are going to tackle another issue when it comes to object detection. This is the problem of dimension or shape, or more correctly, aspect ratio. Some objects, like cars and buses, are going to be very wide compared to their height. Other objects, like people, are going to be very tall compared to their width. In addition, we might be looking at a window, where both objects might appear in the same window, with one occluding the other. The only way that we, as humans, can tell the difference is by the context of the surrounding image. Of course, if one object is completely behind another object, it wouldn't even appear in the image, so in that case it doesn't matter. This case you see here should work, however, if we have any hope of achieving human-level perception. Let's start with some motivation. Let's take the common task of trying to find people. We know that people are tall. So, because I want to build a people finder, I make my window a tall window. But now we have a problem. This person is not tall because this person is lying down. Of course, you and I have general enough pattern recognition abilities that we can still tell this is a person. So how can we teach an object detection system to do the same? The solution that SSD proposes to the problem of shape or aspect ratio is to have preset default boxes, where for each window, we're going to check if that box contains an object. It's a simple and fast solution. It's interesting because it's sort of the opposite of regression. With regression, in particular localization, we were trying to find the box. Now instead, we have the box. We just have to decide if something is there or not. So that's a pretty neat trick. For each window, we're going to test to see if the object fits into one of those default boxes. We have the small square, the big square, the tall rectangle, and the fat rectangle. Now, just as a small detail, we do still have to do some regression, but it's easier because we are constrained by the box. So as an example, suppose I have this person again, but now I'm not limited by my tall person box. My tall person box says that there's no person, which is fine. My big square and my small square also tell me that there's no person, which is fine. But my wide person box says that there is a person, which is perfect. An important fact about default boxes is that they are applied at every scale. So in this image from the original paper, we can see that the dog, because it is large, is found at a larger scale, but the cat, since it is small, is found at a smaller scale. And they are both found using different shaped default boxes. So in SSD, we combine the two ideas from this lecture and the previous lecture. We not only look at the image at multiple scales, but we apply each default box to each window at each scale. So even though we discuss each of the pieces of the system separately, in SSD they are all working together to achieve state-of-the-art performance.